These are the Unit 7 study guide answers for questions number 20 through 22. The very first question is talking about some isotopes, number 20, saying draw a Bohr model for each of the isotopes and fill in the information. So what they give us first is the isotope notation, and they're asking us to draw for nickel 58. Remember that 58 is the mass number, and it tells us the number of protons plus the neutrons. So the atomic number is 28, since all nickel has 28 protons. Mass number is 58, protons 28, electrons are 28, and neutrons are 30 because of this mass number being 58. Since protons are 28 for all nickel, and in this isotope the mass number is 58, which again remember is the protons plus the neutrons, 58 minus the protons will tell us the neutrons, 30. For the drawing, I've drawn this a little bit differently from class in order to fit it into this space, but it's all the same information. Protons and neutrons are in the center, and I've drawn 4 different rings because nickel can be found on the 4th row of the periodic table, and the number of electrons goes 2, 8, 8, 10. Here are the answers for the other 2, but they were found in the exact same way. Here's potassium. Potassium has 1 electron in its outer shell. And there's neon. Neon is what's called a noble gas, which means that it has a full outer shell without having to be an ion, and it has 8 in its outer shell. For the next section, for number 21, it's asking us to draw a Bohr model and a Lewis diagram for both. So I'm going to start off with the Bohr model. For the Bohr model, I've drawn the similar notation as above in order to save some space, but it's got all the same information. Sodium has 11 protons, 12 neutrons, and so that filled out the center. Now remember, we're drawing for Na with a 1 plus charge. It's an ion. Since it's a 1 plus, that means that an electron was taken away. Normally, sodium could be found on the 3rd row of the periodic table right here, and which means that it would have 1 valence electron. But with a 1 plus charge, that means that an electron was taken away. So when that electron was taken away, the next layer of the Bohr model was exposed, and that's this one right here with 8 on it. And that's why I've only drawn 2 shells. So for the Lewis diagram, please remember that a Lewis diagram, the purpose is to show how many valence electrons it has, and this Bohr model shows that there are 8, and that's why our Lewis diagram has to have 8 dots. For the next one, we're being asked to draw for silicon with a 4 minus charge. So here's what that's going to look like on a Bohr model. For the Bohr model, I've got it drawn here. It's going to have 3 different rows, and that's because with a 4 minus charge, we didn't have to jump or lose any of our shells. Silicon can be found right here, number 14, and if I'm going with a 4 minus charge, it means that I'm adding 4 electrons. 4 minuses have been added to it. So that's going to bring us 1, 2, 3, 4 in this direction. We stay in the same row on the periodic or on the Bohr diagram. So it's going to still have just 3 rings. And they're there, right like this. And it's going to have a grand total of 18 electrons, 14 normally. And we've added on 4 because it's an ion. So that gives us 2 plus 8 plus 8, just like that. Again, remember that the Lewis diagram shows valence electrons, and as this ion is drawn with 8, it should look like that.